Alright guys, I'm going to get to do a project today that I've wanted to do for a really long time. Ever since I first discovered these things. And this is a wind turbine grid tie inverter. Very common thing that you can see on eBay, Amazon and such. It takes in 3-phase, allegedly deals with up to 2,000 watts of output. I have had many times over, basically since starting this, people asking me about information on these things, and they've always been outside of the budget. And even still, this is way outside of my budget. But I've been asked enough times that I just went ahead and grabbed one. And we're going to see how it's made, and we're going to see what it can do. I'm going to try hooking it up with both my i2000 and my Healy 2.0 and see which ones work better with it. They both have completely different power deliveries, and I'd like to see how this thing can handle either one of those. Now, this is something I always hate mentioning this and avoid it most of the time, but as I said, this is not really in my budget. If you find this information useful, helpful in any way, there's a PayPal link in the description below. If it's worth a couple of dollars to you, donate to the channel. Anything donated to the channel gets reinvested in the channel. This actually had to come out of my pocket because all of my channel's budget is allocated. But we're going to, basically looking at the outside of the thing. There's nothing special. I don't know whether or not I like the paint finish, the blue, because it's powder coated. It's got a texture, and one of the things, I don't know if it's going to show up on camera, but let me point my other light over here. If it works with a little bit more light this way, which it does not, because now I'm just in the shadow. Without it being a glossy finish, there's like texture in the paint, and it's like this. This is just, I touched it with my dirty hands, and I've tried to clean that off. It's just going to be dirty forever now. Not really a big deal. It's aesthetic. It doesn't affect how the thing works. Actually, I'm going to turn that light back off because it's making it difficult for me to focus on things. The input side is very straightforward. I really don't know what those would be for. It does not have a manual with it. I'm assuming that remote means it has some kind of remote switch. Who knows? We're not going to run it with that. Dump load connections. The exterior connections of this thing are pretty straightforward, very easy to understand. This is going to be the tricky side for anybody in the United States. Now, if you are in a 230 volt country, then it's really straightforward. You have a hot line, a neutral line, and a ground. In the United States, our 230 volt circuits are two 130 volt circuits that work in series to add up to 230 volts, a neutral line, and a ground. Now, running this to a US 230 volt circuit, you would run your line to, like, your neutral here would be another, your other hot, your L1 and your L2. Basically, whatever measures up to 230 in your box, that's what you're going to run this with. But because it's not really made for that, I wish they made these things for the American market. But they don't, and that is life. I'm gonna lay down just a little bit of a barrier here. Just a little bit. Now the back side of this thing is a massive heatsink. I do like that. It is surface mount though, and my panel is wood, so it's still going to be mounted on standoffs. I'm pretty sure that this heatsink can handle a lot, but yeah, I'm imagining that all of our MOSFETs and everything are just surface mounted on the inside here. I can see there's all kinds of screws and everything mounted to the inside. Let's see how this thing is put together. Grab my screw holder, which is, you know, if you're doing stuff like this, this is always a great idea. It's a little neodymium magnet. Unless you're dealing with okay, our display is attached to the cover. Okay, so first thing that I notice, and I can't see the screen on my phone, I am trying very hard to make sure that all my stuff stays in view. Our lines going to our dump load. We'll talk about the dump load here in just a second. This is coming from the circuit board, and this is one of the AC phases. We've got all three phases. They come in. This is our rectifier right here. Those are probably temperature sensors or limiting sensors, something. Okay, so this is our rectifier. Our three phases come in here. This is one of the AC phases going to one side of our dump load. The other side goes to the circuit board. I'm not sure. There are there's two relays here. I'm willing to bet that whenever we start seeing a voltage spike, both of those relays trigger and shorts all three of the phases. This is 10 gauge wire going from or going to the dump load resistor. There's also coming off of the rectifier, the output side. I've got two 10 gauge wires on the negative, two 10 gauge wires on the positive. Now, on the AC side, because this is supposed to be a, you know, being able to push 2,000 watts at 230 volts, 2,000 watts at 230 volts, 8 amps, something like that. This looks like 14 gauge wire. I would like to see that a little bit bigger. This is on the output. And interestingly, you know, AC1 and AC2, that's what they're labeled on the inside here, is green and red, ground is green and yellow. That's not uncommon. So there's nothing really super special going on in here. I really expected to see a large bank of MOSFETs, which there are. There's a bank on either side of MOSFETs. This right here, this is a heatsink tube. There's fins going in the back, and there's a great big fan. I say great big fan. There is a 40 millimeter fan here that's going to be drawing through, and then there's also two probably 60 millimeter fans that are going to be, or those are pushers. So these are pushing air through. I'm guessing that's probably also pushing air through that way. I would have expected to see It's trying to draw air off of the heat sinks, but it is what it is. There are 2 fuses internally. There are no fuses or breakers on the outside of the inverter. There are 2 fuses that are hard soldered inside. They're both the 30 amp fuses. So I do foresee, that might be an issue at some point. Blowing those fuses, you'll have to open this up and take care of this the old-fashioned way with a soldering iron, or by replacing these with something, with some leads and a fuse holder. Okay, so that's really all that's inside there. I really can't, I'm not sure if I expected to see more than that in there or not. Let's get it flipped back over and put back together. Okay. Now the other considerable thing that this inverter comes with is this. This is a resistor, which I bet, I don't know if I can open that up. Yes, I can. This is just a fiberglass tube. No, can't get to it. It's glued inside this cap. But this is just a fiberglass tube with some resistor filament inside. I have very little doubt that this thing can actually hold up to 2,000 watts. Which I guess the hope is that it won't have to hold up to 2,000 watts. It'll just have to hold up long enough to bring the turbine down to a reasonable speed or something. We'll see. And of course, it has little holders for this. But this is, I find this amusing. This actually looks, fairly, I mean, it doesn't shock you with quality. It doesn't scream, I am made of the best stuff. But it also looks pretty decent, especially compared to things like this. Oh, this is the Solar Edge inverter that basically does, claims to do the same thing. And this thing, now I can't say that this thing, after finding turbines that work with it, it actually worked okay, but they don't have this inverter on their website anymore. Or no, what is it? Cutting Edge Solar, Cutting Edge Power is where I got this one from. But this thing, like you can see, it's not like this has spent time out in the weather. It's just been in the shop, and yet still, the label is almost completely unreadable. This paint doesn't make me feel like that's gonna happen, but this is the kind of thing that I would expect to. It's just cheap. It's just super cheap, and does not inspire confidence. The resistors that actually came with the Solar Edge inverter that I'm making fun of are Cutting Edge. I keep wanting to say Solar Edge. These are actually, heavy, good resistors. This thing feels like it's gonna burn up and melt. Okay, so I'm going to get this mounted, and we're going to connect it to the i2000. and we're going to see how it performs. Okay, so I just have it hooked up to grid power right now. We're just going to go through some of the menus. This is, oops, there we go. So I'm trying to use a new to me gimbal. Help me kind of keep some of this stuff a little bit more steady. I don't think I'm going to use it for this kind of thing, but okay. So this is our power menu, power view, which that's going to show us what our grid power is. It's going to show what voltage is and what our wattage is. Let's go back to this grid waveform. You know, if that's helpful. Our settings menu. And I haven't had a chance to play with this much. I mean, I wonder how you're supposed to... No, that's how. Okay, so let's go back to this. No, we're not going to save any settings. This is always your enter, your set button. Energy menu. No, I guess that's going to be how much power you're making at what time. And then the last menu that's here is your time, date and time, which is, you know, that's self-explanatory. Alright, so we're going to hook the Healy up to it and see how she performs. Okay, so I've been out playing with this thing for a little while now, trying to find that sweet spot that makes it work. This is not very neat. I will try and find a way to have that going back together a little more neatly in the end, if I even bother to keep trying the thing. Okay, so right off the bat, so this thing is supposed to work with a 45 volt to 90 volt turbine, and it does not. It starts grabbing voltage well under 45 volts, and the issue is and I mentioned this earlier with this little dinky resistor. Here, let's show you what happens. Which I actually don't like doing because well, we'll do it with the i2000. So there's two primary concerns here, and that's one, that resistor is live all the time. It is always sending a little bit of current to it, and that is making it difficult for turbines to start. Okay, so our i2000 is spooled up. We're going to hook it up here. We're going to disconnect that. Okay, and because there is automatically resistance on the line, it just brings the i2000 to a stop. Brakes are on. No worky. Okay, so let's we're gonna give this a minute to spool up. You guys might actually see I'm gonna have to bring down the i2000 this weekend because it's got a wobble that has to be addressed. It's unloaded now, so I don't want it to stay that way for very long. Okay, so it's got it 40 volts. And this is the first thing is that this kind of wind, it should be making hundreds of watts, and over here it would be. we got to wait for a really good gust to come along. See, even now, it should be going. And it's struggling. Struggling. It's dropped it all the way down to 9-8 volts. Oh. Looks like it might try to pick up a little bit, but it's probably not. Yeah. I mean, everything, like the Healy's making 2,000 watts, and this thing can't even get started. All right, so let's unload it for a second. 1, 2, 3. Let's not leave that run for very long because that'll be too high. Okay, so here's the thing. Let it spool up, and it goes straight to 100 volts, 120 volts, and it doesn't have the power to stop it. It can't bring it down. The only reason that it actually came down is because the wind died. Even that input voltage too high. All right, so let's load it back up on the batteries because that is getting hot as hell. See over here, connected, 500 watts, 800 watts, but nothing over here. It's still going to hold that up until, I don't know. It's still trying to cook that thing. So we're going to disconnect it. The amount of heat coming off of that's incredible. I am going to have, that is definitely not going to be safe to stay there. So I don't even want to hook it up to the Healy to show how that works. We're gonna put the brakes back on the i2000. But this is what I think is interesting, and also what I'm trying to get away with. In order for these inverters to work, I have to have batteries. The appeal of this is I'm not supposed to have batteries, but if I don't have batteries, that thing shoots up over 100 volts almost instantly and causes problems, and it never comes down. Hooked up to the Healy, while the Healy is still hooked up to my batteries in these inverters, they seem to work together awesome. And really, in my mind, I think it's because that resistor just doesn't work. I did try running these resistors with it to see what would happen, but these are rated for a 12 volt circuit. They are, I don't know if that's, you know, useful information. I don't know a lot about resistors, but I know with those that resistor hooked up, it wouldn't even get started. It would just be on the brakes immediately. So this is going to take some playing around. I think that there's a possibility I can make it work, but I don't know. I'm going to start by getting a more appropriate resistor and seeing what that does for us. Yeah. So stay tuned. I will have some more updates on this thing. I do want to see it work. I want to see this be successful. It's not going to be successful, I don't believe, with a proper 48 volt turbine, especially one that's capable of making 2,000 watts. Our voltage is just way outside of its ability to handle. I mean, like right now though, like I said, it's working together with the existing system with the Healy, but it ain't doing it on its own, and that's a problem. No. All right, like I said, stay tuned. There will be more, and thanks for watching. Have a nice day, guys.